If you're missing or something, you can go back, or if you need extra help tonight, you can go back and watch the video that way. So it gives you an opportunity to be able to get to some of that information. Okay. There we go. Okay. All right. Now it's working. So we're going to start off. When we ended last semester, we ended looking at how to name covalent compounds. Now we're going to spend some time talking specifically about covalent compounds, how they're formed, how they share electrons, and what their structure looks like. So that's kind of where we're starting today. We're going to get kind of the bare bones of that in today. Remember that covalent bonds are between your non-metals. They are formed when electrons are shared between two atoms. Sometimes they share more than 2 electrons. For example, sometimes they will share 4 electrons. That is called a double bond. Sometimes they share 6 electrons. That is called a triple bond. We have 2 types of covalent bonds where sometimes the electrons are shared equally and sometimes they're shared unequally. So if we are looking at a polar bond, that's where the electrons are shared unequally. And if you remember back to electronegativity, that's kind of how much an atom wants an electron. If you do a difference between that, so for example, and you don't have to know these numbers, I'm just giving you for examples, okay? If we were to take like carbon, which is a 2.0, and we were to take fluorine, which is 4.0, well, that's probably not a good one. Oh, this doesn't let me erase the regular way. Sorry, I remember now. If we were to take carbon and we were to take, let's do oxygen, which is 3.5. There we go. The difference between those two would be 1.5, right? If we subtracted these, it would be 1.5. So that would make that a polar bond. And that means that one of these, and it's going to be the oxygen, is going to kind of hog that electron that they're sharing. Okay, that's what it means by being a polar bond. And we'll get into more of that later this week. But the electronegativity differences for those are 0.4 to 1.7. Nonpolar bonds are 0 to 0.4. And that's where they're shared pretty much equally between the two. So for example, hydrogen and oxygen, their electronegativity difference would be 0.1. It's pretty evenly distributed at that point. In polar bonds, like I said, the electrons are shared unequally. In nonpolar bonds, they're shared equally. Covalent compounds can exist in any state, either a solid, liquid, or gas, as opposed to ionic compounds, which were all solids at room temperature. Covalent compounds in any state, or can be in any state, because they have low melting and boiling points. So for example, a solid here would be like table sugar, would be a good example of a solid. A liquid would be water, and a gas would be the oxygen that you're breathing right now. So they can exist at any temperature, or at one given temperature, they can exist in all states. Like I said, the ionic compounds are always solids at room temperature. Okay. All right, let's see if we remember how to write these compounds out. So for water, I think you guys are familiar with that formula. The covalent compounds are usually pretty easy to write as far as their naming is concerned. If they give you the first name and there's no prefix in front, that means that there's only one of them. The prefix di means 2. So then that tells you how many of that element you have. So di is 2 and oxide is oxygen. So you're going to have 2 oxygens there. Okay. So your list for those was mono, di, tri, tetra, like Tetris. Do you guys remember playing Tetris at all? Where they had the 4 blocks. They're just arranged in different ways. Penta, hexa. Hexa has an X, just like the number 6. Hepta, octa, like octopus. Nona, and deca, like decade. All right, diatomic elements. What a diatomic element is it's an element that exists when it's by itself. It's always paired with another one like it. So have you ever seen the formula? You guys probably did this in biology last year where they had your C6H12O6 plus what was here? You guys remember what was there to make H2O and CO2? Remember what you need there? Breathe deeply. What are you breathing in? What do you breathe in? What do you need to live? Oxygen, yes. So oxygen was here. Do you remember seeing this formula last year? Cellular respiration? You don't remember seeing that at all in biology? Well, this is your oxygen. Have you ever seen oxygen written where it has a 2 down here? You seen that? Like some people have oxygen tanks that they carry around with them and stuff. That's the way oxygen's written. Okay. So if you've seen that before, that's the way oxygen is written. And there's 6 other elements that are like that. So when they're by themselves, we collectively call them the Brinklehoffs. So, shoot. So bromine is one of them. Iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. So these are called our Brinklehoffs. And when they're by themselves in nature, they always hook up with another atom. And that has to do because they're so highly electronegative, they don't want to be by themselves. So if you remember, if you need a to help you remember with those, I've got a ceiling tile here with them on it. I have one right there with the Brinklehoffs on it. And then I have 2 more over on that side of the room as well. So those are your Brinklehoffs. And they actually there's 7 of them. And if you do nitrogen over to fluorine and then down to iodine, they actually make the number 7 on the periodic table. Now there's only 6 here, but then you have to grab hydrogen to make your 7th. They make the number 7. You can kind of see over on that one ceiling tile over there where we've got the number 7 kind of drawn out with it by the big hydrogen there. All right, next one is carbon tetrahydride. So carbon, there's no prefix in front. Hydride is hydrogen. And how many hydrogens do I have? 4. Yep. Okay, because remember this is 1, 2, 3, 5, 6, 7, 8, 9, and 10. All right. So see if you can take a minute to finish out. There's 4 more. See if you can figure out what the formulas for those last 4 are. All right, how did you do on those? Workout? You remember how to do those? That makes sense. This is the easiest of all formula writing. If you're still struggling with acids and bases or ionic, you need to come and see me and get some extra help in the morning because you're going to have that for second semester, okay? All right. Let's see here. So I'm going to show you how to do Lewis dot diagrams. You should have a periodic table. If you need a new copy, I have copies here. If you need a new copy of the periodic table. I'm going to give you mine, because mine's going to have these little numbers on them, and that way we're consistent with those numbers. If you need those to be able to do, your ionic covalent stuff. These little numbers here. Take a copy of mine. You don't need them for today, but you're going to eventually need them for that chapter. All right, everybody set? I keep extra copies of this up here. These orange papers, they're right here under the flag. So if you ever miss yours or lose it or anything, just come up and grab another copy right there, okay? All right, so remember when we did first semester, we talked about Lewis dot structures. Did they talk about Lewis dot structures in your class? How many dots they have? So the first column gets 1 dot. The second column gets 2 dots. We skip our D block. And then it's 3, 4, 5, 6, 7, and 8. And they needed a full 8 for there to be filled and be satisfied. Okay? So draw that dot diagram for each atom. Make sure you place the electrons in the correct order. So you don't want to double up until you have them all around. So for example, carbon has 4 dots. I'm going to do another carbon over here. Okay? You don't double up until you have dots around the entire thing. Okay? So 1, 2, 3, 4. Nitrogen has 5 because when I count these, it's in the 5th column, assuming I skip the D block. So 1, 2, 3, 4, and then I double up. It doesn't matter where you put that 5th one, whichever place you want it, it's fine. Traditionally, it's usually drawn on the top, but it's not, a deal breaker. For oxygen then, oxygen has 6. It's in the 6th column in the periodic table if you take out the D block. And so try to get those on opposite sides, but other than that, that's oxygen. Okay? Makes sense? All right, anybody not know where I got the information from that I drew this? What's up? All right. So when we're drawing these Lewis structures, you're going to put the atom with the lowest electronegative. That's going to be your central atom. The atoms are typically listed in the formula with increasing electronegativities. Halogens then and hydrogen can never be the central atom because they've only got 1 electron left that they need. They've only got 1 available spot. So they can't be in the center and have other things, more than 1 thing to them. All right. And then you need to pair all unpaired electrons. So here we have phosphorus and chlorine. The one that's listed first is typically going to be your center atom. So I'm going to put phosphorus here. I'm going to draw the electrons around phosphorus. And then I'm going to see where my chlorines can fit in. How many electrons does my chlorine have? Each one has how many? Which column is it in on the periodic table? 7. So it has 7 electrons. So I'm going to draw a chlorine here. And I'm just going to use X's so you can kind of distinguish between the electrons around the chlorine and the phosphorus. All right, so I've got one place there. I can pair up this electron here with another chlorine. And this one with the last chlorine. Okay. Then go back and double check to see if you have the right number of electrons placed. Phosphorus has 5, plus chlorine, I had 7 times 3 is 21. That's a total of 26 electrons. So I have 26 electrons on here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. I'm good there. So I've got all 26 electrons placed. Does everything have a full octet? Meaning, does it have 8 electrons each? So phosphorus has 2, 4, 6, 8. He's good. And each one of my chlorines now has 8 as well. So we are good there too. All right. My carbon and my bromine then are my next one. So carbon is going to be my central atom. It's listed first in the formula. It's going to have 4 electrons. Anybody not know where I got the 4 from? Good. Okay. My bromines have how many each? How many does each bromine have? 7. Okay. So I'm going to draw a bromine in here, and I'm going to give it 7. So 1, 2, 3, 4, 5. Whoa. Hello. There we go. I don't know where that went. 6, 7. 1, 2, 3, 4, 5, 6, 7. Next bromine. 1, 2, 3, 4, 5, 6, 7. And my last bromine, because I had 4 of them. There's 1, 2, 3, 4, 5, 6, 7. So I had 28 here, and then this made 32 electrons. So I need to make sure that I've got 32 electrons. So 2, 4, 6, 8. 8 times 4 is 32, so I've got that. Does everything have a full octet? Meaning, does everything have 8 electrons? Well, the carbon has 8 now, and each one of the bromines, by sharing, has 8 electrons as well. So that guy's good. All right, so see if you can spend, we need to talk about double bonds, don't we? Okay. So here is my carbon. Here's my carbon. I've got 4 electrons on my carbon. My oxygen has how many each? 6. All right, so at this point, I have 4 and 12 is 16 electrons. So I have all 16 done. 2, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yes. I have all 16 electrons placed. Does everything have a full octet here? Does everything have 8 electrons? Yeah. Yeah. So does oxygen have 8 electrons? How many electrons does oxygen have? How many does oxygen have? 7, right. Carbon has 6. So we have a problem here, okay? And what you have to do at this point, we can't bring any more electrons on board. We've got the maximum number of 16. There's no more to place. So what we have to do is we have to start pulling stuff into the center to be able to make this work. So I'm going to take these 2 away, and I'm going to represent them with a line. So that's representing those first 2. That's going to represent those first 2 electrons. Then what I'm going to do is I am going to pull this electron and bring him into the center. And I'm going to pull this electron and bring him into the center. And I'm going to represent that with a line as well. Okay. Each one of these lines is 2 electrons. So now my oxygen has 2, 4, 6, 8 electrons. So it's good. My carbon has 2, 4, 6, 7. And this oxygen only has 7. So what can I do to deal with this situation? I'm going to take these 2 and I'm going to pull them away, and I'm going to represent them with a line. Then I'm going to come back and I'm going to take this electron and this one, and I'm going to pull them into the center, and I'm going to represent that with a line as well. Okay. See if you can do the next couple of these. How many oxygen? Put the oxygen in the center. Put your oxygen in the center. Put 6 electrons around it. Hydrogen always is always be on the end. Good job. Yep. Good. Hydrogen's always on the end. Always has to be terminal. You need another hydrogen on there, so it's H2O. Hello there. Did you get one of these packets for you? Jocelyn? Yeah. Is it Jocelyn?
No, Christina.
Let's see you on here. Let me look you up over here.
Wait, hold on. Oh, this is a different schedule, I think. My schedule got like changed.
Yeah.
2 different times.
What's your last name, honey?
I'm proud of it.
Okay. Let's see. 5th hour. You're supposed to be in culinary arts with Weisky in B22.
What's after that?
Then you come here for 6th hour.
What's after?
Then Fayed,
Oh, okay.
and then photography.
Okay. I have a different schedule.
Yeah, this is what's on there now. Do you need me to write this down for you?
Yeah.
Okay. So, B22 culinary arts. And that is 5th hour. And then what lunch do they have? Yeah, first lunch?
I had this one.
Yeah. Okay, good. You wouldn't have missed them. 6th hours here. 7th hour is show mouse. Move this one back up so we can see the answers. Fayed, so PE, and that is with Meredith. And then photography, 8th hour is 126 photography. I better write. So take that so you have that because she's going to take your pass. If I give you a pass, she'll take it. And then you're going to culinary arts. And it is 6th hour. No, it's 5th hour, sorry. Open cut Tuesday, 1/18/21. And it is 12:05. Oh, no, 12:10. All right. There you go, dear.
Thank you.
Honey, bathroom? Yeah, it's fine. All right. So for the water here, again, your oxygen, your hydrogens always have to be on the end. They only have 1 electron that they can work with. So you've got your oxygen in the middle, and then you've got your hydrogens hooking up on the sides. So you've got 1 hydrogen coming in here, you've got 1 hydrogen coming in here. Your hydrogens only need 2 electrons to be full. Okay, they don't need 8. It's one of the exceptions out there. It just needs 2. Your NH3 then, your nitrogen has 5. That means your hydrogens are both going to come in. They'll be able to fill in the spots here, here, and here. And at this point, that nitrogen then is going to have the 8 electrons it needs. The hydrogens will have the 2 electrons that they need. For fluorine, each fluorine has 7 electrons. Okay? So when you hook them together, that gives them 8 each. Now, the oxygen is going to be a little trickier. That's going to be like the previous one. So for the oxygen, it has 6. Okay? When the other oxygen comes in, it's going to hook up right here with its 6. The problem is that it's not, at this point, each one has 7. Okay? They need 8. So what you have to do is you have to pull this one into here, and you have to pull this one into here. And that's called a double bond. And typically, the double bond will be drawn with a line there, the way that I've got it drawn up here. Okay? Each one of these lines represents 2 electrons. So 2, 4, 6, 8, 2, 4, 6, 8. Both of them have 8 electrons now. They're good. So we've got to pull out 10. For our nitrogen over here, and those, that oxygen and the fluorine and the nitrogen are examples of those Brinklehoffs, where when they're found in nature, they're not in their, they're in a pure form. They always hook up with another atom like themselves. So for my nitrogen, it has 5 electrons. So each nitrogen has 5. Okay. I can't add any more electrons in. So I can't get to like add extras in to make it 8 electrons each. So what I have to do is I have to start pulling things into the middle. So I'm going to pull this guy and this guy into the middle. And then I pulled this one and this one into the middle. And now everything has, I represent those with lines, 2, 4, 6, 8, 2, 4, 6, 8. And we're set. Make sense? Okay. Got a couple more we can get done. Now these next 2, let me do them up here so you can kind of see what's going on with those. This next one has a charge here. And did that one have a charge and I just didn't draw it in? Oops, that's AP, sorry. Yeah, that has a -2 charge or -3 charge. Okay, so that just didn't get drawn in. What this charge here, and this should be a -3. Yeah. -3, there we go. What this means is that this is a charged particle. That means that it's got an extra electron. So when we're doing our electron counts here, we have to add an extra one in. So chlorine has 7. Each oxygen has 6 each for a total of 18. Plus we have 1 extra here. So 8 and 18 is 26 electrons, I believe. All right. So when I draw this, I'm going to put the chlorine in the middle. And it has, oh, wait a minute. Can I do this? I don't know if I want to do this one for you guys because I didn't talk about expanded octets, did I? Yeah. Oh, I think we can still, yeah. I don't know that I want to do that one with you guys. That one gets icky. We're not going to do this one. I'm trying to give you easy ones. All right, phosphorus has 5 electrons. Everybody cool with that? Oxygen has 3 times 6 is 16, plus this extra 3 here. So it's 8 and 16 is 24 electrons is how many we should have placed around here. Okay, so my oxygen, I'm going to have it over here. So there's my oxygen, it's 6. I got another oxygen here with its 6. And I've got another oxygen over here with its 6. And at this point, you're like, but we don't have 8 here. Well, remember, we had these extra 3 that we can play with. So I'm going to put 1 here. I'm going to put 1 here. And I'm going to put 1 here. When I do that, I have to put brackets around this to show that that's carrying a charge. Okay? Your homework tonight is, I didn't get that page done. What do I want for your homework tonight? Your homework tonight is these 7 problems right here. Okay. So 8-2, you've got 7 problems right here to do. And we'll come back and talk about some more of these tomorrow.